Hello everyone, welcome back to our channel. So after superposition theorem, now we are going to discuss about Thevenin's theorem. Thevenin's theorem is also a network theorem which is used to solve a complicated networks. So what's the basically Thevenin's theorem states? The Thevenin's theorem states that a linear bilateral active network can be replaced by an equivalent voltage source and a series resistance. It is also used in a linear circuit as well as the superposition theorem. So how to solve a Thevenin's theorem? So basically the basic idea to solve Thevenin's using Thevenin's theorem is a circuit having a voltage source and a load resistor and equivalent resistor. So we have to given the voltage source and the Thevenin's voltage, and using both of these we have to calculate the current and the voltage through this load resistor. So how we calculate? Let's see. So we directly use a numerical to understand that. So in this numerical, there is three sources. One is 4 ampere current source, 5 ampere current source, 6 volt voltage, and two resistor. One is one ohm and 2 ohm resistor, and a load resistor. This is 3 ohm. So the problem states that we have to calculate the voltage across this 3 ohm resistor. So we have to calculate the voltage. So now what we do, using this 4 ampere, 5 ampere, and 6 volt, we calculate the equivalent voltage, that is Thevenin's voltage, and using this 1 ohm and 2 ohm resistor, we calculate the Thevenin's resistance. So let's see how we do that. So so at first we see that we first the calculate that there is two current source. One is 10 ampere and 5 ampere, and we cut out the load resistance. We first cut out the load resistance, and there we see that in this point there is no load resistance. So first we calculate the Thevenin's voltage, and we calculate the Thevenin's voltage. This 10 ampere and 5 ampere both are connected in parallel. Here and here both are connected in parallel. So when two current sources are in parallel, we have to add them. But here 10 ampere is going upwards and the 5 ampere is going downwards. So the equivalent is 10 plus minus of 5 equals to 5 ampere. And the 1 ohm and 2 ohm both are connected in parallel. So after that we calculate, simplifying this, we calculate the Thevenin's voltage equals to 5 volt. Then we sort out all the sources, the current sources. We sort out all the current and voltage sources, and here we see that 1 ohm and 2 ohm both are connected in series. And in series, we know that in series circuit we have to add the resistors. So in this case we got 3 ohm. After finding all the V Thevenins and R Thevenins, we now create a equivalent circuit that is connected is voltage source as 5 voltage, a resistor, a Thevenin's resistor is 3 ohm, and a load resistor is 3 ohm. We see that here 3 ohm and 3 ohm are connected in series, and we have to calculate the voltage through this load resistor 3 ohm. So basically we use here the voltage divider law. So what is voltage divider law states? The voltage divider law says that the total voltage into the load resistor by the equivalent resistor. The equivalent resistor both are connected in series, so 3 plus 3. So we can easily found the voltage through this load resistor is 2.5 volt. So accordingly, both the many problems are there. So we see the PPTs, and now we are going to discuss about the last theorem, that is called Norton's theorem. So Norton's theorem is the dual of Thevenin's theorem. So in Thevenin's theorem, we just calculate Thevenin's voltage and Thevenin's resistor. In Norton's theorem, we have to calculate the Norton's current and the Norton's resistor. As simple as that. So let's do a problem. So here is a problem. There is two resistors 5 ohm and 10 ohm and two voltage sources 10 volt and 5 volt. We first connect the AB junction point and then we calculate the others. So we have to connect them A and B, and then we create the loop. Two loops are there. Using loop analysis, we calculate the Norton's current. So using loop analysis, Norton's current is 2.5 ampere. And after that, we sort out all the sources, and after sort out all the sources, these two are connected in parallel because there is two different junctions here. So here we can calculate the Norton's resistor, and then easily in the load resistor, we using the current divider law. Using current divider, we can easily calculate the load current. So the basic difference between Norton's and Thevenin's theorem is, in Thevenin's theorem we use the voltage sources and we calculate the Thevenin's voltage, and in Norton's theorem we just use the current sources and calculate the Thevenin the Norton's current. That's it. Thank you everyone.